Okay, students, we're going to continue on with the section 5.4, which is on solving radical equations. Remember the previous video, as well as what we discussed in class earlier today, were primarily on square root problems that involving square root. In this case, as you can see in front of us, is a cube root, right? It's a cube root. So cube root, in order to get rid of the cube root, you have to basically cube it in order to get the root out. But algebraically, you can also think of it this way. So I can also rewrite this as x minus 1 to the 1/3 power and equal to 2, right? So in this case, in order to get rid of the 1/3 power, it makes sense that we cube that side of the equation. By doing a cube on the one side of the equation, we also cube the other side. Now you remember this portion, this is a power to a power. You remember the property, the exponential property we talked about earlier in section 5.1. We talk about a to the x. Oh, actually, I'm sorry. X to the a to the b, right? X to the a to the b. X to the a to the b simply just means x to the a times b. So in this case, we can say that this is x minus 1, 1/3 times 3, right? Power to a power. So you multiply those two numbers. On the other hand, on this equation, you see, notice how I solve problem. I don't jump ahead, right? I know that it's 1/3 times 3 is 1 already, so I could simply just do something over here. But I want to be patient. I want to make sure my solution right out is nice and neat, logical, step by step, so that as I develop this habit of solving problem in a neatly organized fashion, it allows me to have the tool to hold much more complex problems later on in the future. So this is a discipline, a habit. So I'm not rushing myself. In this case, I go on to the next step and I say, okay, on this side, what happened next? 2 to the 3rd power, very simple, is 8. Okay, so now I can clean up this next step is to clean up the previous step. So x minus 1, that's it, because 1/3 power to the times 3 is just 1, so it's a whole thing to the 1 power, right? So I can write it again. This is just 1 power and then equal to 8. This is just an extra step I write. So then I say x minus 1 is equal to 8. Okay, so by doing so, then I can solve for x. So x is equal to 8 plus 1. X is equal to 9. Now, again, in all these problems, because we have done something to the equation that is materially changing the equation, right? We cube the equation on both sides. Fundamentally, you have altered the function, the original intersection of two functions. So you gotta check back the answer to see that whether this still fits the original equation or not. So we gotta check with original, right? So we check with original 9, put the 9 back into the previous part. So I'll put it right here. I'll do the checking right here. So we got cube root 9 minus 1, and then 2 on the other side, and then there's an equal sign, but we don't know if it's true, so put a question mark there. So in this case, it becomes cube root of 8, 2 right here, question mark. Now cube root of 8 is just cube root of 2 to the 3rd power, which simply means 2. So 2 is indeed 2. So we say, okay, this answer checked out. Our answer is 9. Okay. So here is a radical equation, but instead of square root, we got cube root. But notice, I also take the root and I explain it in such a way that I turn it into a rational exponent, which means is the exponent is a fraction. And by doing so, you can also see the reason why I cube the equation on both sides. So let's go to the next problem, which then you will see why this point that I just made is relevant. This problem right here, pretty complicated, right? You have a trinomial inside the parenthesis, and this parenthesis is to the phi half power, right? Phi half, right? It's a rational exponent and equal to 1, which is actually a saving grace. 1 to any power is all going to be 1, so that's actually nice to know. But how do we treat this? If it's phi half power, that simply means it's the whole thing to the fifth power, but also have a 1/2 power. 1/2 power simply means radical square root. So it's a square root and with a fifth power, right? So in this case, on this side, x squared plus phi x plus phi to the phi half power. What I can do is I can have it expanded to the 2/5 power. To the 2/5 power, the whole thing to the 2/5 power. But if I do so, I must also take the right side of the equation and apply the 2/5 power to the right side of the equation as a whole. Saving grace, 1 to any power is 1, so I can quickly write down 1 on the right side. On this side, as you can see, power to power is multiplying, and when you have 5/2 times 2/5, that's just power 1. So you end up with x squared plus phi x plus phi to the power 1. Well, to power 1, you don't really need to write the whole thing in parentheses anymore. So you can say this is x squared plus phi x plus phi is equal to 1. So then you got x squared plus phi x, and then you subtract 1 on both sides. So you got 4 plus 4 is equal to 0. Now, then we are in a territory that we're very familiar, right? So this is a quadratic equation set equal to 0. We can factor. A lot of these kind of problems is set up in such a way that you can do a very nice factoring so as to easily solve this problem. So you can factor this and set it equal to 0. So we know that this can be x plus 4 and x plus 1. So which means that x plus 4 is equal to 0, x plus 1 equal to 0, x is equal to -4, and x is equal to -1. Now remember, we got to check. So we got to check again. Check with the original. Right? Check with the original equation. So that's gonna take. It has to take. Let me write the equation over here so that because it's the original equation is going to go out of the screen. So I'm going to put it right here just as a reminder. So as we check, you know which equation we're using. X squared plus phi x plus phi to the phi half power is equal to 1. So that's the equation we want to check. So we're gonna take this -4 and I'm going to put it in here, right? So we got -4 squared. Make sure we parentheses the -4 plus phi times -4 plus phi, and then the whole thing to the phi half power. Now question mark. Does it equal to 1? Well, let's see. So -4 squared is 16 plus phi times -4 is -20, so -20 plus phi to the phi half power question mark is equal to 1. So then back here, 16 minus 20 is -4. -4 plus 5 is 1. So you got 1 to the phi half power is equal to, is it equal to 1? Sure it is. 1 to any power is equal to 1. So 1 is equal to 1. So this one checked out. So we say, okay, x is equal to -4. X equal to -4 is one of our answers. So now we go over here and then we say let's check x equal to -1 and see if x equal to -1 is indeed also a solution. So let's take a look at this one. Again, looking at my left index finger here, I'm using the same equation and using the -1 applying to x. So you got -1 squared plus 5 times -1 plus 5, the whole thing parentheses to the 5 half power question mark is equal to 1. So let's see, -1 squared is 1. 5 times -1 is -5, so minus 5 plus 5, the whole thing to the 5 half power is equal to 1. Well then, 1 minus 5 plus 5 is just equal to 1. 1 to the 5 half power. And indeed, 1 is equal to 1. So that also checked out. So it turns out we have two answers. And they both apply to this original equation. So there you have it. Two answers. Okay. So here you have this example of an equation that is still dealing with root. But in this case, it's a more complicated root. Not only is a square root, but also to the 5th power. So rational exponent becomes 5 half. Let's take a look at the next one. This one looks a little more complicated. So you got a rational exponent on one and regular just whole number exponent on the other. 3 half and 3, the 3rd power. So the idea right now is a way to get rid of the rational exponent. So between the 3 half and the 3, if I were to apply a common factor to make sure that both the 3 half and the 3 will become on both sides become a whole number rather than a root, that's the number that I'm going to apply as the exponent. So in this case, let's take a look at this. What if I apply 2/3 on both sides? Let's take a look at this. X plus 18, this is the 3 half power. So I want to get rid of 3 half power, and one way to think about it is I can apply the 2/3 power on that side. So if I do that on the other side, x minus 2 cubed, I also got to do the same. I also have to do the same by applying a 2/3 power there, and the equal sign remains right there. Okay, so that's what I'm going to do. Take a look at this, right? So 3 half times, so power to the power means you multiply these two things. So you multiply these two, right? So remember, x plus 18, you end up with 3 half times 2/3. So I'm just going to write extra step just so that in case people get confused. X minus 2 to the 3rd power times 2/3, right? Power to a power. Remember, x to the a to the b means x to the a times b. That's the property that I'm using, exponent to exponent. Okay. All right, moving on. By doing so, 2/3 times 3 half times 2/3, that just becomes 1. So the whole thing to the 1 power, then hey, x plus 18 is freed of any root, any radicals. On this side, on the other hand, you have 3 times 2/3. 3 times 2/3, well, 3 cancels out, you end up with 2. So you end up with x minus 2, the whole thing squared. Okay, so now we're back into the kind of equation that we know, but we do still have to simplify this a little bit more, just so that we can get to a place where it's easier to solve. On this side, on the left side, hasn't changed, so I'm going to be patient, keep it the same. But on the other side, I'm going to do a binomial expansion, right? A minus b squared is equal to a squared minus 2ab plus b squared. So we end up with x squared minus 4x plus 4. Now, this then, as you can see, we got an x squared here, and this is a polynomial. So I can move everything onto the right side. And to set it equal to 0. So I will subtract x on this side, on both sides, subtract 18 on both sides. And then what do we have? We got 0 equal to, right? X squared minus 5x minus 14. Okay. So now this, as you can see, this is a very simple factor form, trinomial that we can factor. 0 is still equal to 0, and in this case, what we can do is a 7 and a 2, right? 7 and a 2, and they gotta become a negative 5x, so I gotta have a negative 7, and then positive 2, right? So that means x minus 7 is equal to 0, and x plus 2 is equal to 0. So x is equal to 7, and x is equal to negative 2. Okay. Now, I got to check. Remember, I got to check with original. Alright, so now again, for the ease of reading, I'm going to write the equation, the original equation over here, just so you can see how we're applying back. So we got x plus 18 to the 3 half power equal to x minus 2 to the 3rd power. So that's the equation I want to check. So bring it down here. Let's take a look at this. So we got 7 plus 18 to the 3 half power equal question mark 7 minus 2 to the 3rd power. So 7 plus 18 7 plus 18 is equal to 25, right? So 25, so got 25 to the 3 half power is equal to 5 to the 3rd power. Now if you think about it, right, 25, 3 half power, one part of the 3 half power is 1 half power. 1 half power is square root. I mean, if you think about it this way, is that this is essentially square root of 25 to the 3 power, right? So if that's the case, right, again, question mark, 5 to the power. This is square root of 25 is 5 to the 3rd power. Well, 5 to the 3rd power is indeed 5 to the 3rd power, which is 125. So this checked out. This equation checked, this solution checked out. So we say x equal to 7 is one of our solutions. So now we gotta check x equal to negative 2. And let's see if that will check out or not. So we got, again, map it back to the original equation. We got negative 2 plus 18, 3 half power, question mark, negative 2 minus 2 3rd power. So in this case, negative 2 plus 18 is 16. 16 to the 3 half power. And in this case, over here on this side, we're done with negative 4 to the 3rd power. Okay, on this side, notice this basically is square root of 16 the whole thing to the third power. Again, question mark, negative 4 to the third power. So square root of 16 is 4, so it's 4 to the third power, negative 4 to the third power. So question is, are they the same? Well, to the third power, so let's take a look at this. 4 to the third power versus negative 4 to the third power. If today is 4 square versus negative 4 square, square will turn negative into positive. So that would be, and no, you wouldn't have to worry about the negative, it's the square. But this case is cube. So you're talking about negative 4 times negative 4, which gives you a positive. But you had to times negative 4 again, which gives you a negative answer. 4 to the third power is always going to be a positive answer. So positive answer is not going to be a negative answer. So no, not going to be the correct answer. So you're going to turn this answer and you're going to cross it out. And you're going to say this is extraneous solution. And that is how you do this problem. So let me recap a little bit again. Is that you have an equation with a fractional exponent, rational exponent. Find a way to get rid of the fraction and see if you can get to a whole number. So in this case, we tried out having both sides of the equation and apply the 2 third power on both sides of the equation, and then you end up with this process. Okay, if you have any questions, just slow down the solution, the video, or go back to the video and review it, and you should be okay. Okay, I hope this helps.